Welcome to EDU World Space.
From equation 1 of problem 29, we have that h prime a, the angular momentum about a, is equal to the sum from I is equal to 1 going to n of the positions Ri prime crossed with the momenta of the particles Mi, Vi prime. So that's our definition, our expression for HA prime. And we saw that we could write this as sigma from 1 to n and rewrite Ri prime as Ri minus Ra. And we can cross that with Mi and do the same for V. So Vi prime is equal to Vi minus Va. So we have an expression for HA prime. Now let's differentiate this expression with respect to time. So that gives us h dot, which is dh dt, for h prime a is equal to the sum as I goes from 1 to n and differentiate, giving the follows. So this is r dot I minus r dot a cross with Mi Vi minus Va, essentially using the chain rule, plus the sum going from 1 to n, leaving the r as constant. So Ri minus Ra cross with Mi, and now differentiating the velocities. Vi dot minus Va dot. So here we have an expression for HA prime with respect to the time derivative. So from here, we can see that Ri dot is simply the r dt. So the rate of change of position is simply the velocity. And Vi dot, the time derivative of the velocity of the particles, is the acceleration of those particles. And similarly for point A, the time derivative for the position vector of point A is the velocity of point A. And the time derivative of the velocity of point A is the acceleration of point A. So if we use these expressions back in our equation for HA prime, we can simplify that equation. So therefore, the angular momentum HA prime, or h dot A prime, is equal to 0, since V cross V is 0, plus the second term stays. So that's a sum from 1 to n of Ri minus the position of A, Ra, cross with the masses of the particles Mi into the acceleration vectors Ai minus the acceleration of point A, Aa. And so let's simplify this further. So this is sigma as I goes from 1 to n of Ri minus Ra cross, and Mi, Ai, is simply the forces acting on particles I. So that's Fi minus Mi multiplied by AA, the acceleration of point A. And essentially, again, we have two sums here. So we can write this as the sum of I going from 1 to n of Ri minus Ra cross with the force Fi minus the sum of I from 1 to n of Mi into Ri minus Ra, and that's crossed with acceleration of point A, AA. So we split that sum into its two parts. But if we look at this first part, sigma of R cross F, this is essentially Ma. So the sum of the moments about that point A minus the second term, which is M, the mass of the system, times R bar, which is the mass center of that system, minus Ra cross with the acceleration of point A, AA. So we can see that H dot prime is equal to Ma. So H dot prime is equal to Ma if and only if the second term falls away. So if M into R bar minus Ra cross with AA is equal to 0. So for that to happen, this condition is satisfied under one of three conditions. So this happens if A, obviously AA, is equal to 0. That is, the frame is Newtonian. Secondly, so either one of these conditions need to be satisfied, the center of mass R bar is equal to Ra. So point A coincides with the mass center of the system. Or the last condition is that AA is parallel to R bar minus Ra, which is the acceleration of point A, AA, is directed along the line AG.